Okay, in this video we're going to finish up 6-1, the law of sines. We're going to find the area of oblique triangles and also see a real-life problem solved in there. So for area of a triangle, think back to geometry. Area is 1/2 base times height. Down in the corner here I have a generic oblique triangle, and the area of that is going to equal 1/2. The base is easy, that would be side C. But the height, I got it marked in here, this red dotted line, the height of this triangle here. So let's try to figure that out. If we're going from angle B's perspective, angle B, the height is opposite, and then this side here, A, would be adjacent. So the sine of B is equal to opposite over adjacent, excuse me, opposite over hypotenuse. So h over a. So to get this h by itself, we'll multiply both sides by a. So this becomes a times the sine of b is h. So if I replace this h with a times the sine of b, we've got the formula for the area of this triangle. Instead of 1/2 base times height, in this case it's 1/2 c times a, those are two sides, times the sine of the angle b. We could have also done that from angle A's perspective, and also from angle C if we made the base of the triangle one of those other sides, A or B. So we actually, for the area, have three formulas. Area of an oblique triangle, the area of any triangle is 1/2 the product of the length of the two sides times the sine of their included angle. That is, area is 1/2 BC sine A, or it's 1/2 AB sine C, or it's 1/2 AC sine B, depending on what angle you're working from. Notice each letter is only represented once. A, B, C. A is the angle. A, B, C. C is the angle. A, B, C, B is the angle. And note that these even work when the angle is 90 degrees, because the sine of 90 would be 1, so it'd just be base times height. Oop, and there's that glitch in my Mimeopad. If I try to write, it's going to jump, so I'm going to have to try to avoid this area throughout the video. Example 6. Find the area of a triangular lot of land. Two of the side lengths are 90 meters and 52 meters. The angle in between them is 102 degrees, as shown in the figure. I did not put the figure in the notes. So if we just draw a little triangle here, ABC. Actually, we don't even need to label the sides. We got 90 and 52 are the sides. Oops, that's pretty bad. 90 and 52, and it says their included angle is 102. It's important that angle has to be the included angle. It can't be one of the ones outside there. So the area is going to equal 1/2. We multiply the two side lengths, 90 and 52, and then we take the sine of the angle that we were given, since this is based on the law of sines. And we just punch that into our calculator. The area is approximately 2,289, and they did give us units, meters, so that would be meters squared, since we're finding the area of something. And now an applied problem. Okay, we got here a boat race. The course starts up here at point A, and then it proceeds into the direction of south 52 west. So from this point, if we go south and then break 52 degrees to the west, we're heading to the next leg of the boat race. And then we get to point B. Then at point B, the direction changes to south 40 east. So we're looking to the south, but we're going to break 40 degrees to the right or the east to go to the last point, point C. When we're at point C, finally we go back to point A. We just head straight north, and that is 8 kilometers to the finish line. Approximate the total distance of the race course. So what they're asking us for here is the distance around. We've got this side is 8 kilometers. We need to find the two missing side lengths here, and then add them all up, and we can get the length of the boat race. And where we stand with the information given, we're not ready for the law of sines yet. We only have the one side 8 kilometers. We need the angle across from that side to set up a proportion. So we are going to need to find angle B. So we're kind of stuck. We do have this other angle outside of our triangle, this 40 degrees here, but we need the angles inside the triangle. Most specifically, we need angle B. So we're going to have to think back here to geometry. This line here, B to D, is based on one of our bearings. You remember this is a north-south line. From point C back to point A is also a north-south line. So these lines are parallel. If I draw across them, oops, there's that glitch. In blue, this line would be a transversal. So back to geometry class, parallel lines crossed by a transversal. This angle here that's 40 degrees is alternate interior to this one. So this one will also be 40 degrees. Okay, so let's work back here to find angle B. If we take 180 total minus the 40 minus the 52, angle B is 88 degrees. And that's the key there. We do need to set up law of sines. So directly across from the 8-kilometer side is the 88-degree angle. So we can write 8, oop, there's the glitch. I'm going to move down here. 8 over the sine of 88 degrees is equal to, well, let's see here, we could, let's do A over the sine of 52. Side A, which would be this one down here, across from the 52-degree angle, sine of 52. And then we can also set up one for the last one for C, C over the sine of 40. Side C would be here, oops, whoop, there's the glitch, C over the sine of 40. Now I guess I can put this where that glitch is. And if we start cross multiplying from here on out, it's just the law of sines applied. So if we cross multiply here to get A by itself, A is going to be 8 times the sine of 52. A is going to be equal, we're going to multiply the other diagonal, 8 times sine 52. Oop, that's supposed to be sine 52. And we're going to divide that by the sine of 88. The sine of 88 to get that variable A by itself. A little bit button pushing on the calculator is going to tell us that side A, I'm going to write it up here, A is approximately 6.3 kilometers. Remember our units here are kilometers. And we solved for A and got 6.3, but we did round it. So to solve for C here, I would cross multiply this one, 8 over the sine of 88, with this one here. Try to use the given information as much as possible, because when you introduce rounding, it does introduce error to the problem. So let's see here, to get C by itself, we're going to multiply on this diagonal, 8 times sine of 40. And we're going to divide that by the sine of 88. And we push those buttons on the calculator, and we get C is approximately 5.2 kilometers. Okay, again, the problem they're asking us to is what is the complete distance around the course, or what would be the perimeter of the triangle. And if we add up the given 8, the sides that we just found there, you're going to get about 19.5. About 19.5 kilometers. Okay. Here's a couple for you to try. So pause the video, give these a try, start the video back up, and see if you got them correct. Okay, for the first one, that's just an area problem. Triangle, a lot of land. We've got the two given sides, and then we have the included angle. So this one, our area, is just going to equal 1/2. We multiply the two sides, the 24 and the 18, and then multiply that by the sine of 80 degrees. Make sure your calculator is in the correct mode. If you got everything punched in there right, you should get about 212.7 yards squared yards. And now this one here is a lot like our second example. The thing that might be tricky for most people is figuring out the angles, trying to think back to geometry. So here now it's basically the same thing, but we're talking about swimming. We want to find the entire distance around here. So we want to find the perimeter of the triangle. We need to find those missing sides. Okay, and they did provide us with the picture here. So let's figure out all these angles inside. The first thing I'm going to do is extend this north-south line here. So these parallel lines do go on forever. And then this one here is our transversal from A to B. And they gave us this 28-degree angle. So alternate interior, this would also be 28 degrees. Now this is slightly different from the example. Here from D, radiusing around here, we have a straight line. So that would be 180 degrees total. So we can use that to find this missing angle B inside. So if we take 180 and subtract 58 and the 28, we're going to get 94 degrees. I'm going to write it here and then move it in because I think that's where my glitch is. So this is a 94-degree angle inside our triangle. So we've got the 28-degree angle, we've got the 94-degree angle, so that leaves up here 58 degrees. Oops, I'm going to write it over here. 58 degrees is that angle C, oops, inside the triangle. Oop, there's the glitch. So that's 58 degrees. All right, everything in the triangle is accounted for, so we can set up our law of sines. We're going to have 800 is the only side that we were given, and that's going to go over the sine of 94. And then we can set this equal to, what's that, A over the sine of 28, and C over the sine of 58. And if you punch everything in the calculator correctly, you're going to get A is about 376.5 meters. And C is about, C is about 680 meters. And if you add up those sides that we found with the given 800, you get 1,856.5 meters. There we go. The homework, this is on WebAssign. These are odd ones here. If I get some time, I'll put up an odd problem video for this, but the area stuff is usually pretty simple. So when you get some time, check that out on WebAssign.